I need like a name for this, don't you think? So, like Khan Academy has Sal, and my first name is Allison, so maybe I could do something with Al, like Sal versus Al, but like the the awesome Academy. I don't know. Bonus points for whoever comes up with a great name. Before we get into the riveting material of synthetic division and factor and remainder theorems, I want you all to meet Jay. So, a couple of you said a few days ago that you heard barking in the back of the video. Well, here is the culprit.
You bark? Say hi.
There he is. That's Jay. All right, so synthetic division. I think most of this will be a review for you, but just in case, we're going to go over it like this is the first time you've heard it. So bear with me if you already understand and know it. But synthetic division actually is a shortcut for dividing a polynomial by a linear factor of the form x minus c, where c is the 0. So you would solve for c by setting this whole equation, x minus c equal to 0. And we're going to actually use that c when we are using synthetic division. So using synthetic division, you set up like this. So you're going to set up your factor here. So this is going to be your c value right here. And then you're going to set up each term, but these are just going to be the coefficients of the term. Okay, so let's talk about how that works with this specific problem right here. Our c term is going to be 3 because x minus 3 equal to 0. When you solve for x, you get x equals 3. So this term right here goes into our spot here. And then we're just going to take our coefficients of every term we see here. Now, since there's none missing, we have the cube term, the square term, the single x term, and our constant. We can just put those right in. So we have 4, 3, -1, and 8. Okay, now to perform synthetic division, we apply certain rules. So for the very first term, we're going to bring this term down. So we're going to bring it down to 4, and then we are going to multiply this term times this term, put it in this spot, and then add down to get our new number. So 4 times 3 is 12, so we put 12 here. Now we want to add down, so we want to add 3 and 12, which gives us 15. Now we're going to repeat the process again. We're going to take 15, multiply it by 3, so that gives us 45. So we put 45 in this spot, which -1 plus 45 gives us 44. Now we need to do 44 times 3, so we can bring this out to the side. 44 times 3 is 132, so we put 132 here, and 8 plus 132 is 140. Okay, so now the way we write this is we say that 4x cubed plus 3x squared minus x plus 8 divided by this factor x minus 3 gives us 4x squared, because we're going to do one less term. So we started with a cubed, now we want to start with a square, plus 15x plus 44. And this term right here, this last term, is always our remainder. So like with regular long division with polynomials, we want to write it as 140 divided by our divisor. So our divisor was x minus 3, so we're going to put it like this. So this right here would be the final answer using synthetic division. Let's work through another one together. So again, we see that our factor right here, our divisor is x plus 2, but when we set that equal to 0, we get that x is equal to -2. So that is what we're going to put in our box out here. Now we're going to put all of our coefficients. So our x to the 4th term has a coefficient of 6. Our x to the 3rd term has a coefficient of 11. Our x squared term, though, is missing. Now we can't just skip over it. So like with polynomial long division, when we were keeping our steps organized, we had to put 0 in as a placeholder. So we're going to do that again here. So 0 for our x squared term, -12, and then +7 for our constant. Okay? So now we're just going to follow the same process. We're going to bring this 6 down. So we have 6. Now we're going to do 6 times -2, which is -12. And then we're going to add down. So 11 plus -12 is -1. Now -1 times -2 is 2. 0 plus 2 is 2. 2 times -2 is -4. -12 plus -4 is -16. -16 times -2 is +32. So our remainder right here, remember this last term right here is always our remainder, is going to be 39. So we start with a 1 less degree than what we started with. So this becomes 6x cubed minus x squared plus 2x minus 16 plus a remainder of 39 divided by a divisor, which was x plus 2. So this would be the answer for this division. Now, this is so much quicker than polynomial long division. So whenever you have the opportunity to use synthetic division, now that you know how to do it, go for it. Now let's talk about how we can use the remainder theorem to help us solve problems and mesh synthetic division with that as well. So the remainder theorem says that if a polynomial f of x is divided by x minus c, remember our x minus c is the term, the divisor, then the remainder is going to be equal to this, r equals f at c, which is saying that if I were to substitute my value c into my equation of f, I should get out some number, okay? And that number, in this case with this theorem, is going to be a remainder. And we know how to find the remainder using synthetic division, right? It's always the last number in our term. Okay, so let's look at this word problem here. So the number of tickets sold during the Northside High School football game, okay, let's go ahead and change that to the Timothy Christian High School varsity soccer, right, because y'all don't have football here, which is a shame because in Texas we're all about football. Anyway, the varsity soccer season can be modeled by this. T of x equals x cubed minus 12x squared plus 48x plus 74, where x is the number of games played, and we want to use the remainder theorem to find the number of tickets sold during the 12th game of, remember, the soccer season. Okay, well, this would be normally solved by just substituting 12 right in. So we might say, oh, well, that's easy. I can do 12 cubed minus 12 times 12 squared plus 48 times 12 plus 74, right? I could do that. But you're going to get some big number that you probably couldn't get very quickly without using your calculator. So what we're going to do is we are going to use synthetic division. Okay, so let me erase what we have so far because this is going to be of no help to us. Well, okay, I'm just going to cross it out here. Okay, so let's use synthetic division. So we know our remainder theorem is r equals f of c, meaning that if we were to use synthetic division, the last number r would be what we want. Okay, so let's say that we want the 12th game. So our 12th is going to be our factor out here, and now we want to put the coefficients of our polynomial. So we have 1, negative 12, positive 48, and 74. Okay, now it's just a matter of using synthetic division. So we bring down our 1. 1 times 12 is 12, which gives us 0 when we add down. 0 times 12 is 0, so 48 plus 0 is 48. And this last term, 48 times 12, you might have to use your calculator. You could pull it out to the side, but when you do that, you get 576. So 576 plus 74 gives us 650. Okay, so now the way we would write the answer to this problem is we would look at the remainder. Remember, the remainder theorem is saying that r is going to equal f of c. Okay, so this is our r. So the answer to this question, how many tickets are sold during the 12th game? Well, 650 tickets are sold. Okay, and we did that relatively quickly using synthetic division. Right, we could have used this method up here, but that's going to take too long, right? 12 cubed minus 12 times 12 squared, right? If you didn't have a calculator, that would take a long time. So this is the way to go using synthetic division and the remainder theorem. So in order to understand the factor theorem, let's think of a pretty basic example. So let's come back to this function right here. But the factor theorem says that our function f evaluated at c is going to equal 0. Okay, now don't let the c confuse you. All it is c is the 0 of a function. So let's think of something easy. Let's say we have x minus 2 equals 0. Okay, now the way we find the 0 of this function is by solving for x. So to solve for x, we just say that x equals 2. Okay, in this case, our c is 2. Okay, pretty simple, right? Now let's evaluate our function at 2. Okay, so let's plug our 2 back into this function, and we see that 2 minus 2 equals 0. So because that we got it equal to 0, then we know that c is indeed a 0 of our function. So f at c is indeed equal to 0. So we've shown that it's a factor. Now that is a really simple example, but let's apply that same technique and that same thought process to looking at polynomials. So the polynomial we have here is 3x cubed minus x squared minus 22x plus 24, and we want to determine if x minus 2 is a factor of this polynomial. Okay, now the way to do that is to take the c value, so set this equal to 0 and solve for c, so in this case 2. So we want to see if 2 goes into our polynomial evenly, meaning that after we perform synthetic division, we should get 0 as our remainder. So our goal here is to get 0. If 0 is not in this box here, then we say that x minus 2 is not a factor of the polynomial. So let's perform synthetic division. We bring down the 3. We want to say 3 times 2 is 6. Negative 1 plus 6 is positive 5. 5 times 2 is 10. Negative 22 plus 10 is negative 12. Negative 12 times positive 2 is minus 24. And indeed, we do get 0 as our remainder. So this is telling us that x minus 2 is indeed a factor of our function. So now we have f of x equals x minus 2 times this polynomial right here. So these are the coefficients, and this, remember, is going to be x squared, this is going to be x, this is going to be our constant. So this becomes 3x squared plus 5x minus 12. All right, now we're not done because this right here can be factored. So we want to say that f of x in its fully factored form is x minus 2 times the factors of this quadratic. So we say that 3x and x go here, and then by doing some guessing and checking, perhaps you can determine that this is going to be equal to 3x minus 4, and this other term is going to be x plus 3. So this right here is the fully factored form of our polynomial. And we were able to figure that out because we were told at the very beginning that x minus 2, or rather we were asked to prove that x minus 2 was a factor of the polynomial. And the way we did that was to show that 0 was indeed the remainder. If there was any other number besides 0 in this remainder spot, then we would conclude that the factor was not, or that the divisor, excuse me, so in this case x minus 2, we would have to conclude that it's not a factor of our original polynomial. So that's how we use the factor theorem in order to save us a little bit of work, right? You don't want to have to do long division or even try to factor this out possibly by grouping, right? That's not going to work. So using the factor theorem and our knowledge of synthetic division, we can easily factor any polynomial.